Uh, for so long, I was just telling you all this and with my screen. So, anyways, and now I hope you can see, right? This is the one.
Yes. Yes.
Yeah, yeah, this is the one, isc2.org, right? And you can see the one. This is, I mean, they have got so many exams, out of which this is the first one, the entry level certification, right?
Yeah.
So this
Okay.
you can try. Anyways, others are anyways quite, I mean, advanced, and you need thorough study for them, as well as these are expensive. But at least this we can start with, right? And I mean, I recommend this to almost every student who is entering this field, no matter what age we are, right? We all just start learning at some point of time. We try to upskill as in as many certifications as we want, right? So this it's a good one. Anyways, so I was saying that if you have any questions before we start.
Can you
No.
introduce yourself?
Yeah, sure, definitely. My name is Ahmed, and I've been a trainer for like more than 10 years, only purely training. I've done my BTech engineering in electronics and communications, and I've also done my MBA, right? And I've got a few certifications, right? And I'm currently preparing for this Zscaler one, right? And again, there's so many things, I mean, certifications that we are doing these days. But anyways, so I love teaching, I love training people, and myself also learning new things. So we'll definitely, yeah, tell me.
I'm so sorry. I'm so sorry.
Problems. Yeah, so that is about me. So my core areas are cybersecurity, computer networking, ITIL, right? ITIL V3, V4, and I've also got some certifications in AI and ML fundamentals, right? And that is also basically from Microsoft AI 900, right? And again, one ISC2 CC, and then again I'm also preparing for my CCNP, as well as um, I've also got one certification from Proofpoint for email security, right? And I've got this CompTIA security architect level exam scheduled. I mean, I'm preparing for that, right? So it's a
Okay.
really good one. You must be aware of CompTIA, right? It's a
Yes.
very good organization, right? It has got Security Plus and Security X. Security
Okay.
X is the advanced level, right? It's the architect level certification. I've got this scheduled in a couple of months. I mean, within 2 months. So I'm preparing for this also, right? I mean, this is the go-to certification for all the cybersecurity experts, right? So it's a good one, right? And you can see CompTIA is again a very good uh, vendor neutral, I would say, authority on cybersecurity and other technologies, right? I hope you're aware of this, right? CompTIA.
Yes. Yes.
It's a really popular portal. Yeah. Okay. So that is about me. So let us now start with the with a very basic understanding of how things work online, right, on the internet, because cybersecurity is all about securing the cyberspace, securing the internet, right, and not just internet, securing your infrastructure from the internet, right. So we will start with it, and I do have some proper decks with me, but just that I wanted to, start with it one on one in the call. So I have not, transferred any deck in my this system, right? But anyways, let us start with it, and if I feel the need, I will share with you the some decks as well, notes as well. We've got a lot of PDFs, right? A lot of content is there, but it's just that understanding is the main goal here, that we understand instead of holding on to the PDFs, right? So the very first thing is in cybersecurity, as I told you, we are going to understand a bit about networking also, right? And why is that important? Because networking is the thing that allows us to communicate over the internet, right? And if I start asking you about the internet, like what is internet? What are networks? How would you define a network, first of all? Anything. See, it's just a normal question that we start with, right? So you don't have to be worried about anything. We just are trying to converse here. So what is internet and how would you define internet or network or the infrastructure that you work in any corporate?
It's basically connection of different systems.
Yeah, it's a connection of different systems. Systems could be, what could be the systems?
Computer,
Okay, so let us quickly
Data,
just
routers,
routers,
which
okay, hubs.
so when we talk about infrastructure, we have a lot of things, not just computers, obviously, but we start with the devices. The very first thing is the devices that are there, right? That is, these could be the end user devices, right? The end user, like as you said, your PC, a general laptop that we have, right? PC, laptop, desktop computer, and as well as servers, right? Where we try to upload or download from the data, right? So we have web servers, we have file servers, so many types of servers that we have. Email servers, we have web servers, right? We have file servers we download from, video servers, audio servers, right? For songs and for everything, for Spotify, for YouTube, Netflix, everything. So file servers, and similarly game servers, and so on and so forth, right? So these servers serve us. They tell us, I mean, they answer our request. If we request for a web page, they they give it to us. If we ask for a file, they allow us to download it. If we want to send a mail across the internet through, let's say, Yahoo Mail or Gmail, they allow us to do that, right? We have so many protocols. So let us quickly break it down one by one. So first is the devices, right? And then we also have something called as the networking devices, right? End user devices, which are end user, which are like terminal devices, where the communication starts from and where the communication ends, right? So we've got PCs, servers, and other devices like telephone, your IP phones, right? Your mobile phones, etc. And then we have got the networking devices also, which are intermediary devices, right? So let me complete this one. Mobile phones, IP phones, as I say, IP phones are nothing but the phones which are connected on the network, on the IP network, right? Let's say your the phones that you see in the office, right? Uh, so I hope you're with me right now,
Yes,
right? IP phone is a very popular phone, this one, right? And it works on the using the same internet connection. I mean the same LAN connection that we use in our corporate environment for the PCs, for the
yes,
desktops, right? So yeah. So this is the terminal devices. We call them terminal. Terminal means it ends, right? This is where the communication ends. So terminal, as you know, the meaning of terminal is nothing but the end point, right?
yeah.
I hope I'm not being, really, because I'm starting from the scratch. So if you, not, I hope you're not getting bored here.
No, no.
No, right?
no,
So
no.
yeah. Okay, so that is about it. So then networking devices or the intermediary devices, right? As we say intermediary because these are, they allow us to communicate further. They allow us to connect further to the terminal devices because we just cannot have one device here and one device in the North America, right? There are going to be a lot of other devices and infrastructure between, yeah, or you can say within these two countries, or let's say India and North America, India and USA, let's for example. So there are going to be a lot of other devices in between, right? Or let's say we are just simply using satellite communication, just one satellite. It's a different thing. So just to give you a broader perspective, just to, I mean, if you allow me to explain further, I want to show you something here. Let's say there is the architecture itself is what we call as the submarine cable, right? I'm sure you are aware of this, right? These are the undersea cables. The undersea cables are the under ocean cable that are laid from countries and countries to countries, from continents to continents, right? And they actually create the backbone of the internet. So let me explain that. If you can see, this is a world map, right? And if I just zoom it further, come to India, right? You can see here. Okay, let it load. Yeah, now you can see. So what are these links? Can you see these links here? Colorful links
Yeah.
connecting
Yeah.
countries. These are the undersea cables. And if I just try to show you this, it's called as an undersea cable or a submarine cable. Both are the same thing, right? Undersea cable. Let me show you the images here. Yeah. So these are really thick optical fiber cable, and these are really, I mean, bulky and heavy. And these are placed really secretly under the ocean, just so that we can have the infrastructure set up, the backbone. We call it the backbone, right, of the internet. So these are the ones that allow us to communicate across the globe. Like these are the actual backbone of the internet, right? So let me just quickly click on one such. Okay, just a second. Let me click on one such, let's say CME V4, right? This cable connects Europe to India to Malaysia, right? So like thousands of kilometers long. So this is what I'm saying. These are being like managed by Bharti Airtel and different telecommunication companies across of these countries, right? And everyone comes together to take part in it. So the point is that this is what forms the infrastructure. When I was saying that we ping here, we ping a website, this is how the ping goes. This is how the communication goes across countries, across continents, and the nearest server is chosen. And these are the techniques that we use. That we choose the nearest server first, so that we can have the low latency, right, and all of that. So this is the first thing. That this is the backbone. That's how the internet works. If you have this in mind, you will be able to picturize and visualize how the uh, packets are moving, how the things are moving, and how the communication is happening, right? So I'm sure this helps, right?
Yeah.
Right. So and similarly you have so many other cables by different owners are like Meta, AWS, Amazon, right? And all the major companies that we have across the world, be it telecommunication companies or your social media giants, everyone have they are invested in this. They have invested hugely in these infrastructure, right? So this is much faster and better than the satellite communication. So that is the main idea. So let's come back to this. So as intermediary devices, we have what we call as the very popular ones, the routers, right? Routers allow us, as you know, we will surely dive into routers and routing a bit, so that you can at least we can get some idea as to what routers are and what they do. Because let me tell you, in cybersecurity also, we try to, like when we talk about securing things, we also try to secure our network, because network is one of the one it could be one of the attack vectors. Attack vectors are the ways, through which they try to move further and attack and penetrate the system. So networking is also, the computer network is also has to be secured, right? That's why we have firewalls, we have so many type of cloud security solutions, right? So routing, unless you know routing and routers and how things work, you won't be able to understand the bigger picture, right? So everything is actually really important, right? So routing is done by routers. Routers basically try to find the best path to the next to the destination via some next hop. Let's say we've got so many protocols, like you must be aware of OSPF, right? Routing protocol, EIGRP, these are the major ones. And if required, we will dive into them more in depth. But as of now, I'm just giving you a brief idea. So routing protocols allow us to uh, configure routers in such a way that they can choose the best path forward. Okay, that's a nutshell. In a nutshell, that is the definition of a routing protocol. So routers use these. And today we have these two major protocols that are used across the networks, across the industry, right? EIGRP and OSPF for internal, and for external, we've got BGP. So that's about it. Then comes the switches, right? Switches are again a really important part, because a lot of attacks happen in cybersecurity in which switches play a crucial role, right? And a lot of time attackers try to spoof the MAC addresses, and then the switches are used for that. The switches are actually attacked using those attacks, right? Like ARP spoofing and all. So switches are again the devices, and if I just tell you about the switch, switches are the devices which simply connect, they simply create your LAN, right? So it's like you have this what you call as a um, multi switch board, right? Like we connect a lot of devices using switchboards. We have this kind of switchboard, right? It can connect your phone as well, your laptop, and it allows us to charge. It allows us to charge all these devices just right from one connection, right? Similarly, for computer networking, we have switches as a device. As you said in the beginning, hubs were also used at some point in the history, but now they are not used anymore, right? And these are the switches, right? And again, this is simply a device that allow us to connect multiple computers, multiple PCs together to create a simple LAN, a local area network, right? So that is just the beginning of it, the basics of it. We will discuss more about them in detail. So that is devices to create a LAN, devices to create a LAN. And then they've got technologies like VLAN, trunking, STP, DTP. A lot of further technologies are there in them, just to manage that, just to have better segmentation, better management of devices. So that is mostly part of the CCNA module, I mean CCNA curriculum. If you are aware of that, CCNA is again a certification, and it's a very popular one. So that is about the switches, right? And then we have other devices like, if I talk about further, we have got cloud, right? Not just cloud, I should say WAN network. And WAN is something, what is a WAN? Yes.
Wide area network.
Wide area network. What is it actually? How does it differ from a LAN?
LAN is to connect the local devices, like maybe inside a house or a building.
Hmm. hmm. And WAN is more, as we've just seen, the submarine cable thing, right? This is actually a WAN. Internet is a WAN, a wide
Okay.
area network which further goes across countries and cities and continents. Like Reliance Jio in India is a WAN network. It's so huge, it connects countries. I mean, the cities of a country, right? The states of a country. Similarly, internet is example of a WAN, right? So in WAN also we have a lot of technologies. We have a lot of technologies. Just to start with, I mean, you must be aware of, I'm not sure if you have heard of it, but it used to be the very first type of technology they used to connect countries and cities and continents, the WAN connection using leased lines. But these were really private and expensive, and they started making it better by introducing something called as frame relay, right? Frame relay technology, right? This was again also very popular, like 20 years ago, right? But then it got replaced by something called as MPLS. And then comes the software defined WAN, which is the, I mean, current uh, thing that we use today, right? We use SD-WAN today. We have even replaced MPLS also. Frame relay lead lines are things of the past, right? These are obsolete. Even MPLS is being replaced, and then we have SD-WAN, which is the software defined WAN. So why I'm telling you about this is because when we talk about cybersecurity, these are definitely uh, going to come in the infrastructure part, right? Attackers use technologies. They can twist and turn technologies in their favor. They can create loopholes, right, using these. So everything is, I mean, is part of the picture, right? I hope you're getting my point.
Yeah.
Yes.
So yeah, don't worry, unless it is required, we will not, I'm not gonna be I mean, we will not delving into these in detail. So I don't want to, I mean, intimidate you with these so many concepts and so these words. Just that these are some concepts, and these are actually important and required in the bigger I mean, when we talk about the attack of how things are attacked, how countries attack each other using cyberspace, right? So these are taken into consideration, right? I mean, if I talk about, if I mean, talk about the basics of all these ransom, I mean, all these malware, right? You have so many types of attacks which are done by countries, you know that, right? It's not just ethical hacker doing some phishing. It's not just some hacker stealing something. Cybersecurity today is being utilized for for bigger purpose. I mean, for bigger, as in countries are attacking each other. These are cyber warfare, right? And they are destroying the cyber infrastructure of each other. I mean, the countries using these technologies, right? I'm sure you're aware of that, right? So that's the reason, right? Vinaya Tilaga, I hope you're able to connect.
Yep. Yes, Ahmed. Yeah.
Right. So I was talking about this very famous attack that it's called as Stuxnet, right? I'm sure you must be aware of it. So I'm telling you this is because these are real things. Countries are using these attacks against each other. It was a state-sponsored computer worm, right? Stuxnet. That was actually used by one country against another country's nuclear facility, right? And they destroyed nuclear centrifuges. I mean, where they try to, refine the nuclear fuel, right? For example, uranium or plutonium, etc. So one country destroyed other country's centrifuge just by sending a cyber attack across the across thousands of miles of distance, right? That is the reason these things are I mean pictured together, right? And it was a really famous case. And then we have got so many types of malware. We will discuss that. So this was the I mean, this is why I'm telling you this, that these are important things. These are things that must be understood if we want to understand the bigger picture of cybersecurity and how attacks are placed and how attacks are being started. So that is about the general idea, right? Then before we start with the cyber concepts, let me just quickly tell you a bit about networking protocols, because protocols are like are the very are the most utilized you can say tool that attackers and cyber defenders or attackers they use. Port numbers, protocols, right? And that is how they enter into into a system, into a network, right? So we've got something called as the entry points, basically, right? The entry point. So we've got so many protocols in networking, right? If I talk about protocols, we've got a list of huge list of protocols. But if I try to shorten it for you, I mean, just to summarize things, right? I mean, we've got these models, right? You must be aware of OSI model, TCP/IP model, right? These are really important. And even today, if you choose anyone, any higher cybersecurity certification, just if it's vendor neutral, anyone, for example, Security X, you will definitely find a lot of curriculum being targeted towards understanding of these protocols just that I just told you: OSI model, TCP/IP, right? Protocols, port numbers, right? Let me show you. See, SD-WAN I was telling, right? We have software-defined networking here in security architecture. VPNs, right? I think they have not discussed it here. They have discussed in the beginner level certification, which was security plus the other one, this one. Anyways, networking is actually a prerequisite, right? If you just look into this, they they recommend experience of at least CompTIA Network Plus, which is what we're talking about, right? And 2 years of experience in a security administrator job. This is just a requirement, right? So Network Plus is anyways the basic requirement, right? That is there for every cyber certification out there, right? For a decent level, I mean, good, moderate level exam, right? So N plus for them is like CCNA that we're talking about, right? Network Plus is again this certification from CompTIA for networking, right? A plus, network plus, this one. So this is again a prerequisite for security plus as well as the security x exam, right? So and you can see the ports, protocols, the OSI model, TCP/IP, right? Everything here. Start from right from the cablings to the wireless, and as a matter of fact, let me tell you, these are important stuff. If you have not gone through these, we need to brush these up also, because as I said, these will be utilized in the further understanding of how attack works, how to stop it, and how firewalls are used, what are the policies that we use on the firewalls, right? How to stop some kind of traffic, some kind of protocol, right? That's how we defend. And just to tell you, cybersecurity is a vast, it's a huge field. It's so many things here, right? From the the red teaming, the blue team, the defenders and the attackers, right? And then the security controls, the operations, the SOC analyst, the operations control department, right? And then we also have the GRC, the governance, risk and compliance, right? So that is again a separate field, but within cybersecurity, right? So it's a huge field, it's a huge domain, right? And so yeah, that is about it. So routing, switching that we're talking about here, right? So you can see the topics here: BGP, EIGRP, OSPF, and all of that. So that is the reason I'm talking about this, right? And this is important. We have to have some understanding of these topics before we jump into the core cybersecurity concepts, right? So that is about it. Now, next is, any questions so far, guys? I've taken a lot of time in the introduction itself. Any question you have?
No, so far good. Yeah.
Okay, okay. I hope you're understanding it. I hope you're enjoying the session. If you have anything, you can ask me. It's not a problem. You can don't hesitate. Okay, just if you're not getting something, if you don't understand something, if you have any question, you can just ask me. That's completely fine. Okay. Yeah, okay. So that's about the general idea of WAN, and as I said, routers, switches, and then we have protocols, right? So in a lot of networking books also, like we used to read certain books in BTech also, in engineering, and in graduation also, and which they have divided the concepts of network into three, four parts, just for the better understanding. One is the devices, right? And then second is your I mean actually protocols. Then we also have something called as the media, as in the wired media or the wireless media, the cables, the communication technology, the transmission technology, right? So in this way, if you understand, it becomes really easy for you to remember that how we have broken these things in the what if we want to learn it one by one. So you can break this down like this: devices, which consists of servers and types of servers, and everything, all the devices that we have, be it an end user device or intermediary devices. And then media, wired media, wireless media. So in this we have if I talk about wired media, we have coaxial cable, right?
Yeah.
I'm just giving you a structure here so that if required, we will deep dive into them. And then we have Ethernet cable, right? Ethernet cabling also, cables or Ethernet cable, right? A lot of types of Ethernet cables are there, right? And then we have optical fiber, a very popular media today, right? Wired media. And in the wireless, we have technologies like Bluetooth,
Yeah.
WiMAX. Yeah, Wi-Fi is again a very popular one. WiMAX is also there. WiMAX. We have we have something called as a Li-Fi. If you know it, Li-Fi is actually a really popular one, and but I don't know why it has not been implemented much. Just to give you some idea, because the topic came and I wanted to introduce this. I've not heard about this a lot in the people are not talking about it much, but it came actually about in 2011 or something, right? And they wanted to use light bulbs as Wi-Fi routers, right? So can you imagine you getting light also as well as the internet, right? So this is Li-Fi actually, and they wanted to replace it, but I think due to some limitations they could not proceed with it. I mean, they could not proceeded with it, and they could not scale it up, right? But this was something. This is actually a real thing, right? That using light bulbs for internet, you get light also, and you get that data also, right? So this was it. And then similarly, I think light cannot penetrate walls, right? Light cannot cross walls, unlike Wi-Fi. So that, I think, that is the limitation they faced. So they had to use it in an indoor, some indoor scenario, right? Indoor area. Anyway, so we have Bluetooth, Wi-Fi, WiMAX, Li-Fi, and then cellular technologies. What is cellular? You know?
Yep.
Cell phone.
LTE. Yeah.
Yeah, all these telecommunication technologies mostly, like we talk about, even WiMAX is also a telecom technology, 2G, 3G, all these 4G and 5G, right? So these are again technologies that were being used for sending the data faster, right? And again, these are wireless technologies that we use, cellular or telecom technologies. WiMAX is also part of this same family, right? So these are the wireless. Also, we had something called as infrared, right? It's a mode of transmission, right? Infrared. That is what we use in a lot of sensors, a lot of remote controls, right? That we use at home, TV remote, AC remote, and all of that, right? So these are the major ones, okay? And then the next category is the protocols, right? Let me remove this from here just so that we can have some structure, okay? And so protocols, not but when we talk about protocols, we talk about these models, these frameworks like OSI model, TCP, IP model. So these are really important. And if you go to any job interview, any kind of any interview, job interview mainly, they definitely will ask you about TCP IP model or OSI model and the layers and all these functions, right? I'm sure you must have also experienced this, right? No?
Yep. Yeah.
Yes.
Like mostly if you see, I mean, I've been part of a lot of interviews as well as panels, and not just me but other panel members also used to ask it. And even as a student, when we were sitting in the campus placements, OSI model was the go-to question. Everybody used to prepare for that. That OSI model is the one that they will definitely ask, even in programming interviews, even in general coding, I mean, for freshers, they definitely ask these questions, because that is what tells us the basic idea behind how things work in a network, right? How things flow in a network, right? So can anyone of you explain why, first of all, we need these models before we understand the what of this? Why we need these? Any idea? Okay, you can start with what also. What is OSI model? What is TCP/IP model? Yes.
OSI model is like you're transferring the data between the layers, like application layer, data link layer, transport
No.
layer. Okay.
I mean, you are there, but we do not transport the data between layers. That
Like
is how it
communication.
works. Okay. No, no, there's a difference, right? So I got your point, but it's not how we use these layers. I mean, these are not why we use these layers for, right? And I mean, you have any other answer? What is the use of TCP/IP model, or what is the difference between them? Anything about them? Yes, both of you. If you can please try.
I just know like TCP is a three-way handshake protocol.
Now that is different. Again, you are
Yes.
there, but TCP and UDP, when we talk about the three-way handshake process, these are the TCP and UDP as transport protocols, right? These are as transport protocols, not as a framework. TCP IP is the framework, and TCP
Okay.
and UDP are two different transport
Mhm.
protocols that almost every protocol uses. Like for example, if I talk about your HTTP, like what we are using right now is HTTP protocol. For example, this one, if I just click here, it says Zscaler, the connection is secure. Right? How is it secure? How is it secure? It is secured because it is using something called as HTTPS protocol. Okay, this
Yeah.
HTTPS protocol is the secure version, and the older one was used to be HTTP, just basic HTTP, right? If you look at this, it says there's a log symbol here. This log symbol signifies that this particular website is secured. It is not going to leak your data. It is not sending your data in plain text. It is encrypting your data, right? The data has been encrypted. You know encryption? What is encryption?
Like unreadable.
Yeah,
It's
Yeah, make it
it convert
unreadable.
into a plain
Huh.
text. Yeah.
converting it to unreadable format.
Yeah, some kind of cipher
Local.
text. We call it cipher text, right? Which is jumbled words, let's say hash, anything. It could be anything. It depends upon the algorithm and all, right? But I'm just converting my message into this, something like this, unreadable, some cipher text, and only I can decipher it. Only I can unlock it, right? Or if I want someone to unlock it, I will share the key, right? That is how it works. So, I mean, the point is that HTTP was the older one, the normal protocol, which was without any security. And HTTPS is actually the secure one. Now, why I told you about all of that is because HTTP, HTTPS, or any other protocol for that matter, they all have to use either TCP or UDP. Right. So for example, if I say SMTP, you've got FTP, so many protocols for so many things, they all are going to use either TCP as their transport protocol and or UDP as their transport protocol. And then comes the point about, I mean, then that is where we talk about the TCP and UDP as transport protocol. And again, I think we will have to go through these as well in detail because I mean, it's completely fine. You have been working in a different field altogether, so it's totally fine if you want to brush up these concepts. We will spend some time with these concepts also, right? So TCP IP is different, TCP UDP is different. Okay, I hope this is understood.
Yeah.
Right, let me just complete my point, what I was trying to say. Yeah, so now if you can see this particular picture here, you have got protocols like FTP. Okay, why is it not coming? Okay, just a second. Like FTP, which is a file transfer protocol, SSH for remote access, right? Telnet is for again for remote access of devices. SMTP is for sending emails. All these protocols, be it for email, HTTP for web browsing, HTTPS for secure web browsing, as I just told you, all these protocols are using TCP as the common transport protocol. And we've got so many features, so many good things about TCP that it is always recommended to use TCP when you're trying to have a reliable connection, right? And that is where your TCP three-way handshake comes, as you just said, right? So that is three-way handshake, and that is why we use it. And we will discuss more about it. And then the other part is the UDP. UDP is used when we want faster speed and we are not concerned with the reliability much. There's not much need of reliability in the communication. For example, this video call. If I have this video call or this, uh, conference call here, we focus more on the speed of the packets instead of the reliability, instead of the connectivity. I mean, we do have connectivity concerns, but speed is the main factor, right? In these cases, in real time scenarios, in real time applications, we go with UDP. Is it clear now? I
Yeah.
hope the difference is clear. So we will discuss in detail again. I've just touched, I've just given you the basics of these. Just that TCP and UDP are two different things. These are part of the transport layer, which are the OSI model layers that we have. So the OSI model, if I just give you, so it is again, these are part of transport layer, but these are different from TCP IP model. Now, if you look at this, if I just yeah, this one. So TCP IP model is just a model. It's just a framework which consists of these layers like transport layer, internet layer, link layer, application layer. Within transport layer, we have two protocols, two main protocols, TCP and UDP, transmission control protocol and user datagram protocol, right? That is the difference. And OSI model has quite detailed description of these layers, of these protocols and their function, these layers and their function, and the encapsulation of packet happens here and decapsulation happens here. So yeah, that is about it. So that was a basic difference, right? So again, back to the main question that we started, why we need these models? That's a very basic question that everyone is asked when they talk about networking or these models, that these frameworks. Why do we want to use OSI model or TCP IP model? Any idea?
No.
No, no problem. That's completely fine. I was just trying to see whether we have some understanding of these models or not. Or forget about these models. You tell me what kind of standard you follow in your, let's say, job, your work, your day-to-day, systems. Do we have some standard in place? Do we have some kind of framework in place?
I hope so. It's a TCP/IP.
No, no. I mean,
Sure.
forget about networking. Forget about networking and your these frameworks. Uh, you must be aware of ITIL, right? What is
Yeah.
ITIL?
It's a kind of practice we've been implementing, kind of. I mean, it's,
Hmm.
yeah. What's the waterfall method? I'm not
Okay, okay.
sure.
Let me just make it really simple. Let me just connect it to the something that you use almost daily, right? We all use phones, right? We all use phones, and we have Wi-Fi in our phones, right? If I just show you something, let me show you one thing just to give you a broader perspective. It's not just used in networking or in ITIL, or these are frameworks which are used almost everywhere. This is in a specification list of iPhone 17, right? If you can see this on my screen,
Yeah.
this is WLAN or wireless LAN. Can you see and tell me what is this? Wi-Fi, and then what is this? 802.11 A, B, G, N, A, C, 67. What are these? Can you
No
guess?
idea.
These are really simple. I mean, you
Release
always, hmm?
version.
These are versions, these are variants of Wi-Fi, right? So for example, 802.11a, this came in when Wi-Fi technology began. A came in 2000, 2001, or maybe 1999. A and B came together. 2003, a version G came. 2007 or 6, N came. And every time a new version came, it was having much better Wi-Fi speeds, much better supports of devices, the better device support, right? Better bandwidth. And today we are talking about Wi-Fi 7, right? And 6 and 7. These are the latest ones, right? Older phones do not have these. So what are these? These are the standards given by somebody, some organization, some kind of standard making body. In this case, it is IEEE. Have you heard this name? Yes, have you heard about this? 8 IEEE. This Wi-Fi standard is actually given by IEEE, which I'm talking about here, and everybody uses it in their phones, in their homes, the Wi-Fi router, right? And it is given by whom? It is given by an organization called as IEEE. Can you tell me the full form of IEEE if you have any idea? No?
No.
No.
Most of the engineering colleges have these IEEE as their clubs, as technical clubs, right? Anyways, I mean, this is something that is popular in students, mostly students and researchers. So what is IEEE? IEEE is a standard making body. The full form is Institute of Electrical and Electronics Engineers. You can see here, right? So they have got people from across the world, engineers, scientists, researchers, right? And they come together to create some standards for some technologies, just like I said, Wi-Fi or Ethernet, the LAN, right? Yeah, Bluetooth. Even Bluetooth has its own IEEE standard. You know that every such technology has their own IEEE standard. Bluetooth standard is 802.15. Wi-Fi is what? I just told you. 802.11,
11.
yeah, 11 or 11, right? And WiMAX, I mean, there's a long list of these things, but I mean, if you can remember, you can remember. 802.16 is for WiMAX, for Ethernet cable, for everything like LAN cabling that you use in your office and home, the LAN cables, the red color cables, these are 802.3. Simply Google IEEE 802.3 and you will get a long list of technologies with Ethernet cabling, right? Ethernet cable technologies. So why I'm saying this is because why the standards are important, why do we need standards, is because we want to make technology available worldwide, globally, irrespective of country or company ownership or language or anything, right? So if let's say you want to use Wi-Fi in your laptop, you're a manufacturer based in India, for example, and you want to use Wi-Fi in your laptops, you do not want anything. You don't have to communicate with anyone. Just simply use the foundations, the specifications given by IEEE 802.11 and implement them in your system. You you don't have to worry about the compatibility issues. You don't have to worry about the uh, you know um, uh, whether it will be able to communicate with the other devices which are made in Germany, which are made in Japan, which are made in USA. Everything will work completely totally fine. Why? Because everyone is using the same standard. Are you getting my point now? So the
Yeah.
same standards allow us to make things global, make things compatible with each other. What if you started using your own standards? For example, there is just to give you one example and to summarize this, you have Dell and then you have HP, right? What if Dell is using its own standards of creating laptops and HP is using its own standards and protocols for for creating and manufacturing laptops? What will happen? Tell me. What if they have separate their own standards? What will happen? What could happen?
It
I
will be
think the
hot.
devices cannot communicate with each other.
A lot of times they might not even
Confusing.
communicate with each other, right? And let me tell you, this actually happened in the early days of computing when Apple and IBM were, the only two companies on the planet, right? Two major companies. They were actually uh, using their respective separate protocols, separate standards for their devices. And because of that, they were not able to communicate with each other. Apple was not able to communicate with IBM, IBM was not able to communicate with Apple. But today, if you see, you can use Dell's laptop and use HP mouse, you can use HP keyboard, and it all works fine. Yes or no? Why do they work easily? Why the compatibility is so easy now? Yes?
It's the same processor, same
Yeah.
driver.
No, not
Yeah.
same, because they are using the same standards for the technologies. Now you get my
Yeah.
point?
Yeah.
So if they want to use Wi-Fi, they will simply refer to Wi-Fi standard 802.11 given by some organization, let's say IEEE. If they want to use, let's say, some kind of GPS system, they may go for GPS, GLONASS, or Navik. Navik is actually Indian technology, I think. Uh, Navik, I think, is made by India. I think I'm not wrong. So yeah, Indian, right? So whichever technology they want to use, they don't have to worry about the country of origin or the company that has ownership. Nothing. If that is available, if that is the standard is in place, they simply use the standard and use it, make it. So this allow us to have open source knowledge available to everyone, right? That is the exact reason why we have OSI model in place as well. OSI model actually talks about the open system interconnection, right? So like we have Wi-Fi, we have uh, Wi-Fi, Ethernet cable, and so many other technologies having their own standards, and we don't have to worry about whether the Wi-Fi router is made in Germany or India or Japan. Since it is using IEEE 802.11, it will be compatible with us, right? I hope you're
Yeah.
getting my point.
Yeah.
That is the main reason why we use standards. And similarly, ITIL. Similarly, any other process that you use across the world, uh, even Domino's as a pizza maker, the pizzas that Domino's make, Domino's has a particular standard in place, a particular process in place to create pizzas, to, cook pizzas. No matter whether Domino's New Delhi is making pizzas, or Domino's Mumbai is making pizzas, or Domino's Chennai, the process will be same. The taste and the recipes could be different as per the local taste, but the process of making pizzas will be common, so that they can shift their employees from here to there without any problem. They can use the same material, they can procure the same material everywhere, right? So this is why standards are important. I hope it is clear now, right? I've given so many examples from so many perspectives. Any question now?
No, I'm good for
No.
now.
Right, so I hope you got the Domino's example,
Yeah.
right? So since you use a particular standard, you don't have to worry about the differences or the mismatch. For example, any company in India can send the employee to US, their same branch in US, and they don't have to worry about um, the the compatibility. Why? Because every company, every of their branches across the country, across the globe, they're following the same standards, right? And for IT services, if you talk about IT services industries, we have ITIL, right? So almost every such standards are very similar to each other when we talk about the why. So for IT processes, for IT service management, as we call it, there's ITIL. Even though it is not part of the discussion today, right? Cybersecurity and networking, but I'm talking about the framework. So ITIL is again a framework for IT service management, and the why is same. Why is same, that we want this so that we can standardize our processes. We can make it completely free from any kind of ownership, any kind of dependency on country or language or company, etc. So OSI model is again the same thing, which is open system interconnection, like this one which I just gave you, right? And I mean, we are almost up with the time. It was supposed to be a 1 hour session, right? If I'm not wrong.
Yeah. Yeah.
So no, don't worry. I mean, not a problem. We will definitely continue with this. And if you have any questions so far, you can ask me. I just want you to do one thing. Just since we have started with these concepts, at least go back once I mean, once you get some time, just read about these protocols tomorrow, and let's just discuss the why, the what, and how of these two only. That would be enough. Okay. So why use OSI model and TCP/IP model? What are these, and how do they work? Okay.
Sure.
Would that be good?
Okay.
Okay. Yeah. So before we end the session, do you have any questions? Anything? How do you like it? And whether you have any feedback for me or anything you want to add, any suggestion, please go ahead.
No, Hamid, for me, it's too good.
Okay,
Yeah,
okay, all
it's good.
okay. So yeah, anytime if you have anything, any suggestion, any if you want extra something extra that you were expecting and I have not introduced it, you can simply tell us, right? And we will definitely take care of that. Okay. So just that this is how we begin. This is the fundamental part, right? And just whatever you can see here, you should at least Google it, at least read about it, just casually, so that you know what these terms are. Okay. And we will continue from there tomorrow. Okay. All right.
Sure. Yeah.
Okay. Thank you so much for your time. No need to explain. At least you should be able to, recollect the concepts that we discussed, and definitely it will take some time for you to master it, for you to, be aware of it and able to explain it. But at least start with it, start making notes about it, right? So that you don't
Yeah.
forget, right? And notes are anyways helpful. So okay, let us now quickly continue where we left so that we can cover the networking part as soon as possible, right? And
Yes.
then move on with the other modules. So yesterday we discussed with the basics of networking, as networking is a prerequisite. So it's a completely fundamental aspect of cybersecurity, right? Without which we cannot understand networks, we cannot understand computers, we cannot understand cyberspace, which is the internet and the systems and the servers. So that is the reason we have to be really good at understanding the networks. So in networking, we discussed about things like devices, media, and protocols. These three things actually make up the network, any network, be it your telecom networks that we have, for example, Airtel, Reliance Jio, Vodafone. These are our telecom networks, right? And we are like using them since so many years since we have got our phones, right? So these networks also work the same way, just that these are countrywide. These are connecting our states and cities and country, right? So these are again same. They have devices, they have media, wired media or wireless media. We have telecom towers. We have optical fiber cables that go along in the ground. And again, we have some protocols that these companies use, right? So every network, be it your computer network, be it your telecom network, your satellite network, everything has this format, these three things in place, which are devices, media, connectivity medium, and protocols. I hope this is understood so far,
Yes.
right? Okay, so next is as we were discussing on the OSI model, as we were starting up with it. So you can, we can later on, you can revise it, and if you have any question among these topics, you can definitely ask me. But just that I want to move further with the models now. So the OSI model and TCP/IP model. Let us take care of these two in together because these are really similar to each other, right? As in the like in yesterday's class, I also asked both of you to at least go through these and see what we understand from these, why we use it, what are these, and how do they work. So any concept when you want to explain or learn or demonstrate, use these three things, these three aspects. Why is it being used? Why is a technology useful? Why are we using it? Why are we even studying about it? What is it about? Or what the technology is and how does it work? If you can explain any topic, any technology in these three aspects, it will cover most of the it will have a lot of things for you to explain and understand also. So whenever you're learning, you're exploring something, just understand three things about it, so you will get a better understanding of it and you will be able to explain it also better, right? It is always helpful. So the why, what, and how. So talking about OSI model and TCP/IP model, let me just quickly give you a brief idea about the predecessor of the internet. Predecessors, the ancestor, as we say, right?
Right.
Ancestor, predecessor. So it means What came before internet? Before internet was there, ARPANET came, right? ARPANET was the one. ARPANET is actually it was a project by United States Department of Defense. Like in India, we have DRDO, we have ISRO, right? These space agencies or Department Defense agencies. Similarly, US government also have this DOD department, Department of Defense. And this ARPANET was their project that was basically used to connect different cities together for mainly for military purpose, mainly for the defense purpose, right? And let me tell you, most of the technologies evolve during wartime, during the time of there is a war going on between countries. That is when countries spend a lot of money in the research, right? That is when a lot of technologies evolve. If you look at the history of technologies, you will find that after World War II, most of the technologies have evolved during that time, be it your manufacturing, be it your atomic weapons or nuclear energy, nuclear fuel, right? Your I mean everything, engines, right? Internet also, so it also evolved during the same time. So ARPANET was the predecessor of the internet, and its name is Advanced Research Projects Agency Network. You don't have to remember that, don't have to remember this name. It's just as a history, as a historical significance, I'm telling you. But this is where it began. This is where they have started using TCP IP for the first time. You can see here. So it says that this was the first network that started using TCP IP protocols as the basis of networks. So this, first of all, they tried to communicate universities to universities. So like they started between UCLA, which is UCLA. It's a famous university in US, and Stanford, right? We all know Stanford. So Stanford, UCLA, MIT, Caltech, all these big universities across the United States started building these sites, these communication sites for their countrywide network. And let me tell you, before this, there was no concept of any countrywide network, any WAN network. It was not even, I mean, it was not there, right? It was just conceptual or just on paper. This was the first one, actually, right? And this laid the foundation of the internet. As you can see here, TCP/IP became the technical foundations of the internet, right? That is why I'm telling you about this, right? I hope you're getting my point, Vinaya,
Yes.
right? So that is the reason. So this started as the foundation of the internet, and then TCP/IP became the go-to foundation, the framework for the internet technologies, right? And then we had IP addressing and protocols and the layers. That is how it began. Okay, so this is the context. This is the historical context of how we started. Okay, so they started building these sites from universities to universities, from different universities in Stanford. As you can see here, it is. Let me magnify this. It's not getting magnified. You can see here itself. It says Sanford. It says Utah, the city of Utah in USA, right? Then it also says NYU, the New York University, Harvard, right? So Pentagon, their defense city. I mean the organization that they have for defense, Pentagon and everything. So the whole cities and these universities became the connection points, the point of connections, right, for their network. And this actually began as ARPANET. Okay, so back in 1977, you can see the map and all. So this became the foundation. Now let's talk about the TCP/IP protocol suite and OSI model both. So as yesterday, as I was telling you about the need of these frameworks, why do we have policies in place? Why do we have standards in place? So we want to make things standardize. We want to standardize technology so that anyone can implement it with little help, with little guidance. They can simply uh, learn and read the standard documents. They can understand the policy and framework, and they can implement it. And also it allows us to remove any dependency of technology on countries, on people, on companies. Does not matter whether technology is made by China or Japan or India or US. If it is standardized globally, it will be used by all, right? Wi-Fi, Bluetooth, USB, your Windows, internet, Facebook, all these are freedom. They are free to use. They all have they are available for everyone to use, right? It's not being uh, handled by or managed by only single country, or only single people, some kind of people. It is for everyone, right? It is also a fact that some people are profiting out of it. Let's say Facebook, it's a company, it's a private company, right? So definitely the organization is being run for profit, but it does not mean that Facebook will not be given to other people, those who have not built it, right? Are you getting my point? So this is how technologies are made available to everyone. So be it Bluetooth or USB, or Wi-Fi, Li-Fi, anything, any technology, right? All these protocols. So that's the reason we use these standards. So one is OSI model. It's a very popular model. So how I mean, what is the major idea behind OSI model? OSI model allows us to bifurcate, or I should say segregate, different responsibilities of different network components. So instead of having simply one chunk, one single block of networking or of computing or communication, we divide it so that we can distribute the responsibilities also. And why do we need that? We want this distribution so that we can troubleshoot better. We can fix things better. If it's just one chunk, one single block of everything, it will not be easy to segregate or point out the problems. In computer networks, we get a lot of problems in cables, in cablings. Some cable is cut, some cable got wear and teared, right? Because of weather, because of some rat and all, they cut it. Or let's say there was a problem with the switch, with the routers, with the devices. There was some problem with the firewall. There was some problem with the application software. So if there are so many types of problems, we cannot just have one block. Are you getting my point? This segregation, this layered approach allows us to pinpoint what exactly the problem is and where exactly the problem lies. If the problem is of, let's say, cabling, physical layer things will be checked first. No other layer will be touched. Only physical layer components will be touched. They will be checked, like connectors, cablings, electrical circuits. Right? Are you getting my point, Vinaya? Because
Yes,
I'm just
yes,
speaking, right, and you're listening, so I'm just I have to ask you also that you are able to catch what I'm saying.
yes, yes. No,
So this
you
is the
can
reason.
continue.
So this is the reason why we segregate and why we use this layered approach in so many different layers, like 7 layers, 7 famous layers of OSI model, starting from the physical layer, the very basic layer which talks about the physical features of the network, like cables, connectors. uh, The main function of this is to allow physical communication or transmission of the data. And for that, we also say that it converts, um, it uses bits, the bits like 1010, right? If I say physical layer of the OSI model allow us to have data in form of bits, like 1010, the general binary data, right? It allows us to convert this and send this across the cable, right? So I'll show you that just to give you a quick idea. Let me open a screen, right? And understand this in this way. For example, I've got two systems here. Now let us talk about OSI model in a bit detail, okay? The functionality of OSI model. So let's say you've got two computers, two devices across a distance, right? And you have to communicate. When they communicate, when they try to communicate with each other, right, they do so by using a lot of protocols and a lot of uh, parameters. Now, what are those? Let us talk about this. For example, we simply want a message to be sent, right? A message has to be sent across the computers, right? A simple message using SMS, using Bluetooth, email, just connecting from wire to wire, anything, any medium or any technology, but a message has to be sent. Okay. When a message is sent across, the message is has to be sent in digital format, right? It has to be in digital format. It has to be in um, ones and zeros and ones and zeros, the binary format, right? Somebody has to do it. Somebody has to do the translation, right? So for that, we have a lot of protocols and a lot of other devices, physical devices. So I'm talking about the main idea here, which is encapsulation and decapsulation. This is the main idea, the main fundamental idea behind OSI model, why we use it, why we have this. Let me just quickly put it here. Okay. Now it will help us to understand the whole thing in a very simple manner. Okay. So if you can see here, what is happening here is data is being, okay, just a second. Mm-mm, just a second. So I think this is creating some, okay, I have to redo it. Okay, let me just simply paste it here and minimize this. Even if we talk about the cybersecurity frameworks, we have to understand the flow of data layer by layer, right? The advanced concepts of cybersecurity cannot be understood unless we understand how the network is flowing, how the data is flowing in the network, how the data is getting transmitted from one device to the other, right? That is when these fundamentals are actually utilized and required. Okay, so now let us quickly start. First, we have application layer. So application layer, presentation layer, and session layer, these three layers are mostly called as the software side layer. These are software layers or software side layer because these are not pretty much, they're not used much in the networking as such. These are more concerned with the application side, the interfaces of application with the service, with the network, like protocols. You have HTTPS, FTP, a lot of protocols that we use for a lot of services. They are used by these layers. We will talk about these in detail one by one. But when the data reaches, I mean, from here, the data is, let's suppose this is the data, right? It has some data in it. That data is getting encapsulated, is getting wrapped up with some extra headers, with some extra information so that it can be transmitted to the correct destination. That is a major rule of, I mean, the major idea behind encapsulation. So, for example, if you look at in this way, when you try to send some message to your friend, like in olden days, we used to type letters, right? And we used to write letters with hand, with pens and paper, and we used to write the to and from to my friend, and whatever the address of the friend is, and from is your address from whom it is being given, right? So once you write the letter, you place it in the envelope. Yes or no?
Yes.
You place it in the envelope. Why? Because you want to secure it, and on the envelope you try to write the addresses of the recipient, of your friend, and also your address. That is exactly what happens in the encapsulation process. Let me tell you, let me just make it even bigger for you to understand. Let's say this was the data, right? Now the data which is being sent, it could be an email, it could be anything, it could be your letter, email, image, video, audio, any file, it could be anything. whatever we are trying to send across, that data will be put in an envelope, the same envelope like you use in the letters. The envelope will be given some extra details, like you wrote the address, the to and from, the recipient address and the from address. Similarly, we will write, we will give extra, what we call it as a header, right? Header is nothing but just extra piece of information that we want to add. So on transport layer, this is, which is the fourth layer, because as I told you, the top three layers are just very they're not much utilized in this communication aspect, right? So we start from transport layer. The data comes from the top layer, and at the transport layer will add its header, and we call it, let's say, TCP header. This TCP header will have some information. Information of what? It will have information about the source port address and the destination port address. That is what it will have, that is what it will put first of all. So TCP header will have its addresses like source port, from which port the data is coming from, and destination port, to which port it is going. Okay, like this. It will be given on which layer? On the transport layer. Then the data will come down to, from data link. This will be, I'm just giving you a brief summary here. I'm not going into much details because it is a very elaborate. So once the data comes here, we call it segments, right? The segment is then attached with another piece of, or I should just make it like this. I should make it like this. The segment, the whole segment, which is the name of data transport layer, the segments are attached with another set of header. This time the header will be attached by whom? By network layer,
Network layer.
right? Are you following? It is happening from top to bottom because we are sending the data from here to here. So this is happening from top to bottom, right? So transport layer added TCP header, for example. Network layer will add its own header, which we call as IP header, and which will have IP address information. And we all know what IP address is, right? Everybody uses IP addresses to locate computers on the internet. So it will add a IP header, an IP header, which will again have what? It will have source IP, from which IP address the message is coming from, and to which IP it is going. So same as you wrote in your letter to your friend, right? As we write it on the envelope. The same thing happens with the IP also. We talk about
Okay.
this on the network layer.
Layer.
Yeah, this is done on network layer. That's the main function of network layer. It allows us to add IP addresses information. And then the last part, I mean, not the last, but yeah, definitely the second last. If I just save it, um, okay. So then, and also let me just tell you, the name gets changed. So we as let me tell you, we call these segments. As I was telling you, these are, once they come to transport layer, they are broken down into segments. Once they come to network layer and they are attached with IP header, we call them packets. That's the reason we say packets are dropping, are not reaching, right? We call the data as packets. So we have different names of data at each layer. So now the segment becomes packet
Okay.
because it has now the information of the IP headers. IP header is attached to it. I will also show you these headers. Let me complete this one. Then I will show you the headers also. Yeah. So then comes the second layer, which is the data link layer. At the data link layer, we are added with one more header, and this is the final header, right? So that's all. So we don't have to worry about more headers. It's just three headers that are added. So this another header is what we call as the MAC header. And you know what MAC is? The MAC addresses, right? Every computer has some MAC addresses on the NIC. So every switch has a MAC address. Basically, every port has some MAC address. MAC address are the physical address. And we will discuss that in detail if you want. I mean, it is required obviously because not a lot of people are able to differentiate between the use of MAC address and IP address. Some say these are similar, some say these are a bit different, but it is very important to differentiate between these two. It is these two are very much used in the communication, right? These two are the major addresses that we have, right? So MAC address is being added by the data link layer, which is a second layer of the OSI model. So that is a MAC address or the data link layer, the uh, MAC address is being added here. And just to give you some extra information here, not just a MAC address is added, but on this particular step, on this particular layer, we also add a trailer. So it's not just a header which is added, we also add a trailer. Okay. So this trailer, why we add it? Just in a simple, short one line answer, we add trailer for error detection techniques, right? We want to detect the errors also. So for error detection mechanisms, we add this trailer also, so that the data is not getting changed, the data is not getting uh, disrupted or faulty during the transmission. So for some error detection algorithms, or you can say methods, are also deployed here in the trailer. Okay, we will learn about this in detail later on because I don't want to burden you all these concepts all at once. So let's do it one by one. So trailer and header are added, and then finally at the very end, the data actually becomes what we call it. We call it as a frame, right? So the name is getting changed. You can see here we are calling data as segments. Here we are calling the data as packets,
Packets.
and here we're calling the data as frames, right? So the name is getting changed. I mean, we call these as PDUs, the protocol data unit. At different layer, we call the data with different names. So PDUs or protocol data unit, right?
In data link layer, right? Frames.
Yeah, frames in data link layer. So protocol data unit is a term used at each layer of the networking model for different, I mean, for different layers, different names. So on transport layer, it is a segment. On network layer, it is a packet. On data link layer, it is a frame. And finally, on the physical layer, it is a bit. As I was telling you in the beginning, in the very beginning, that we have bits. Bits. So these frames will be converted into zeros and ones, like ones and zeros and ones and zeros. As per the data, it will be converted, right? And these ones and zeros will be sent across the transmission medium. It could be your wires, your wireless, could be Bluetooth, it could be Ethernet cable, LAN cable, optical fiber cable, anything, any kind of cabling will be used, and they will be sent across as bits, right? So on the physical layer, that is what physical layer does actually, right? So we call them bits, the ones and zeros, right? The binary data. And then this whole method, this whole technique that we have studied so far, all this adding of headers and trailers and everything is called as, what is it called? It is called as encapsulation, what we have just written here. Encapsulation in OSI model. It means
Okay.
we are simply encapsulating and we are combining our data with extra information we call as headers. TCP adds its own header at transport layer. IP header is added at network layer for IP information. Data link layer add MAC address, same thing. Source MAC, destination MAC, everything is exactly same. Source MAC, sorry, source MAC and destination MAC, everything is exactly same. I mean, very much similar that we have added in the beginning. Source MAC and destination MAC. So, right, and that is how we get these uh, the data, the original data reaches the correct MAC address, the correct IP address, and the correct port number. Right? We will discuss about these in detail. Port numbers. Why are we using port numbers? What is the need of IP address? But from for the beginning, for the basic part, this is how it works. This is how these are encapsulated and transferred across. Okay. And now, just to complete this picture, the same thing happens in reverse order on the other side. Because now what will happen? The same process will be happening like if I talk about this transport layer, network layer, data link layer, and physical layer. Physical layer will reconvert these bits which it has received from the sender. This is my sender, right? This is my sender computer, yes or no? And this is my receiver or the destination, right?
Right.
So sender computer, whatever it has sent, these bits will be converted back into what? Into frames by physical layer here. The data link layer will receive its frame. It will remove the headers and trailer of MAC addresses because that is what it requires only. It does not require IP addressing. It does not require port addresses. It is not concerned about any of this. Data link layer only is concerned about the MAC addresses. So it will remove it. It's like decapsulate it. We encapsulate and we decapsulate. Encapsulation means adding something. Decapsulation means removing those, right? So decapsulation will happen here. And then data link layer will send the frame up, packet up. It will be packet at the network layer. Network layer will remove its IP header, which it has added here. Let me change the color also so that you understand. So all of these things will be removed one by one, like they were added in the beginning. They will be removed by these individual layers. Are you getting my point now?
Yeah.
Right? So this is what we call as decapsulation. Every layer will remove its header and data will be sent forward to the upper layer. TCP will remove the TCP header and data will reach upper layers as data alone, as data only, as it was in the beginning, right? So the upper layers like presentation layer, session layer, application layer, they have their own jobs, but these three layers are the very important layer that they add the headers and addresses. So this is the total idea, the complete picture of OSI model, encapsulation and decapsulation, how the data is sent across. So I hope it is understood, it is clear. Any questions so far?
No, Ahmad, it's clear.
Right. So this is the basis of how networking works, how data is sent across, and how any device forwards data, right? So just to show you more about this, just to give you some more idea on, as I said, I will show you headers also. So let's say TCP header. This is what a TCP header looks like. This is a piece of information which is added, which has source port number, destination port number. And then we have other things like sequence number, acknowledgement number, windowing, right? These are for additional support. The main idea is of source port and destination port. The main addresses are these two. And then similarly, if I talk about IP header, you see IP header. This is a this is an IP header which has information of source. Let me use this one. Source IP address, destination IP address. From where the from where the data is coming from, which IP address it is coming from, to which IP address it is going, right? All that information is there. And again, some extra information like type of service, version of IP version 4, IP version 6, other details like time to live values and all. We will discuss these later on because these are again additional information. Let us focus on the main idea now, right? And then finally, the MAC header. The MAC header are what? MAC header consists of MAC address information, the source MAC, the destination MAC. Same, exactly same thing that we have discussed. The source MAC, destination MAC, right? Along with some extra details for extra information. And you can see here data payload, which is my data, right? Which is the data we are working on, this one actually. right? So I mean, this was the packet that came across, right? And now we call it as a frame. So this is the data itself, right? And I told you
Yeah.
about the trailer, if you remember. What is this
Yes.
trailer? I told you trailer is being used for error
Error
detection
detection.
mechanisms. Look at this. It says CRC. CRC is the algorithm that we use for error detection. This is what it is
Okay.
showing here as your Mac trailer. So CRC is nothing but a algorithm basically to make sure that the data is not changed. Okay, we call it cyclic redundancy check. You don't have to worry about this. It is not going to be. I mean, it is. It happens itself, right? It is a part of
Mhm.
the devices. So it just in exam they may ask you, but otherwise you don't have to worry about it. We don't have to configure it or fix it. It is automatically run by default. Okay, so it's just used so that we can make sure there is no error in the transmission. Let's say I sent you some message, right? The message said, hello, this is my number 123. And because of some transmission error, the message became, hello, this is my number 567. So what is this? 123 became 567. Because of some reason, the message got changed, right? This should not happen. Yes or no? When
Yes.
you send WhatsApp message, you expect it to reach correctly, right? That is
Yeah.
what is made sure by CRC. This is why we use these error checking algorithms to make sure there is no error in the transmission. If error is there, it will immediately flag it. It will immediately ask for retransmission. It will say, no, I want use it again. Some error has happened. Please send it again, right? So this is what basically happens in the error checking algorithms like CRC, checksums, etc. Right, but you don't have to worry about it. It's just additional thing. It is something asked in exam. If it is asked, you have to answer. But we don't have to configure it in our networking life, in our cybersecurity environment. It is not required to configure. It runs automatically, right? So this is the whole idea about the encapsulation and decapsulation. So that is okay. Now, yeah. So source MAC, destination MAC, IP addresses, and port numbers. Now, before I move further, I want to ask you whether you are comfortable with these ideas, like what is a port number? You know it, right? If you don't know, you can ask me. We will discuss that. What are port numbers? What are IP addresses? And what are MAC addresses? Yes.
I know them. I mean, I have an idea like what it is.
Okay. Okay. So where do we find the MAC address, if I may ask?
Command prompt. Command prompt. You can check. Otherwise, in my computer, we can check.
Yeah, correct. And what exactly? I mean, I was asking about the hardware. Where is it found actually? You are right that we can check it on the command prompt, right? We can see use command prompt, and we can check the MAC address. We say ipconfig, and we can check it, right? But
Right.
where is it actually placed?
Motherboard. I don't know.
Okay, motherboard. Where on motherboard? It is
I don't know.
actually what we call as the no, no, it's completely fine. I'm just asking so that we are on the same
Got
page,
it.
right? We
I
so it's not a test. It's not something. It's just to so have some idea about these things in a better manner, right? Because these things are often asked in exams also. Like so, these are actually found. This MAC address is embedded. It is fixed on the network interface card, what we call as
Okay.
the NIC or adapter. This one.
Okay.
Yeah. So this is a hardware which is again on motherboard, as you said, but on motherboard specifically, this is what the NIC is. If I say Ethernet NIC, so this is what an NIC looks like, the network interface card, right? This is where we have the MAC address, be it for wired for Ethernet, be it for wireless. You will have for wireless also, you will have an IC. For Bluetooth also, you will have an IC for Bluetooth, right? For almost every technology, you have some card, some kind of network card, which we call as the network adapter or interface card. For example, here you can see the Wi-Fi NIC I'm using right now. right? And this is the MAC address. This is a physical address as we call it, the physical, and it cannot change, right? It cannot be changed at all. Since the time of manufacturing, it is fixed, it is placed on it, on the device, and it cannot be changed. Okay.
Okay.
Yeah, so that is what we have, and it has to be mentioned, because if it is not mentioned in the data packet, data will not reach the correct port. It will not be able to understand whether I am part of the Bluetooth transmission or the Wi-Fi transmission or the Ethernet transmission, right? So it has to be given. That's why we use these data link layer headers. Okay.
Okay.
And then what are IP addresses? You know IP addresses, like it is really popular and we have been using it. IP addresses are of two
Yes.
types, version 4 and version 6. So it is, as we have already know, as we all know, that IP addresses are addresses of computers on the internet. Like we have addresses of our homes. If somebody wants to locate us, they have to find the country, the continent, the I mean the continent, the country, the state, the city, and then the within the city we have neighborhood or locality, right? Then we have a house number, right? Similarly, when we want to figure out, when we want to locate a device on the internet, we have to use IP address, right? Without an IP address, we cannot communicate on the internet. We cannot even communicate on the public internet, right? So that's why IP addresses are required. And similarly, we require IP address here in the data packet so that it can reach the correct destination. Source IP from where it is coming and to destination IP where it is going, right? And next is port numbers. So now tell me, what are port numbers and what are the uses of port numbers? Why we are using it?
Oh, I think it is to receive the packets. Like for TCP, I think it's 23,
Hmm.
something of that sort. I
Yeah, yeah,
think there
correct.
are
You correct.
ports. Ports.
These ports allow us to um communicate across the network, and these are the entry points for us, right? For example, HTTPS, the port number is 443. Every application, they use some ports, right? So HTTP, the normal one, as we discussed yesterday, the unsecure version, it uses port number 80. HTTPS, the secure version, uses port number 443. So this means it is using port number 80 as a source from here, and it is going for 443 as a destination. Every protocol has some port. Every protocol is using some port number, and which we have discussed yesterday also. Let me show you the list. I mean, the list is anyways required to remember. Like you have to remember the list also. These are asked a lot of times in exams also, or at least you have to remember the basic protocols, right? Like HTTPS. This list I shared yesterday. You can simply use this list. Okay.
Okay.
It has major. If I talk about the detailed list, it is a lot. There's a huge number of protocols and port numbers. But for the beginning, we can look at this, and it is enough for us to understand the port numbers, right? This particular list. Yeah. So we've got this here. Let me place it here. Okay. Yeah. So this is what we have as the port number. So if it is coming from some, if the okay, that is cut now. Anyways, so for example, SMTP. SMTP is a protocol we use for sending emails. Simple mail transfer protocol, right? So this is having port number 25. But when it is received on the email, so from the device, from the server to the device, it will be using POP3 or IMAP. These are for email reception, receiving emails. Then it will be using another port number, 110 or 143, right? So
Is
different
it?
protocols have. Hmm.
Is it? I mean, like the way we have NIC cards, right? Do we have port for ports also something in the hardware, or it is like software?
No, these are no, these are no, no, these are mainly application side, and
Okay.
we call them sockets. Yeah, we actually call them sockets. Sockets are the combination of IP address and port number.
Port number.
So we call it
SPI.
network socket. Yeah.
Okay.
So we call them sockets actually, right? And it is basically a doorway. You can see here a doorway for sending and receiving data between two programs. So this is not hardware specific. It is it is like set by programmers, right? By the company standards, right? And these are used like that. So sockets are combination of IP and port. IP we know, and port numbers are also used along with it so as to get a socket as the gateway for us to enter the entry point, right?
Okay.
So these are very much used in programming also for, I mean, for communication and for application for servers, a lot of uses there, right? But for networking part, for the communication part, IP and ports are used separately. Like we use sockets also, but these are also treated separately when we talk about transport layer or network layer, right? So that is why I showed you this TCP header. Yeah, this one. So it says source port, from which port it is coming and to which port it is going. So these are separated, okay, different. All right. I hope this is understood,
Yeah.
right? So that is about it. Let me just quickly summarize, and also let me see what else is left here. We discussed about TCP. Just to finally conclude the whole topic. Now, if I talk about, we have discussed about OSI model, right? Now, OSI model is very similar to TCP IP model. If you can look at the difference here, the difference lies in just in the fact that it is just four layers in TCP IP model. The top three layers are combined into one single layer, application layer. As I told you,
Okay.
these are all software side layer.
Software.
So these are all like treated as one a lot of times. So in TCP IP model, it is actually one layer, just one layer, application layer, which is mostly consisting of the protocols like HTTP, FTP, Telnet, DHCP, DNS, all these protocols which are for services, for email services, for file transfer services, for web services, right? All these services are part of the application layer. Transport layer is transport layer, no change at all. And as a matter of fact, transport layer is called as the heart of OSI model. It is the main core of OSI model because it is the one that defines all these transport protocols, right? If you remember this, yesterday we have discussed this part. TCP and UDP both are, either of these will be part of some protocol. Like if you see any protocol, they are either part of TCP family or UDP family. Why is that? Because these are the transport protocols. Okay, TCP and UDP both are there, but these are not uh, regular protocols. These are transport protocols. So just to summarize, if I'm using FTP, FTP will be transported on the principles of TCP. And if I talk about DNS or TFTP or NTP, they will be transported on the basis of UDP transport. So these are mechanisms, and we will discuss them in detail tomorrow, right? So
Okay.
that is about it. Yeah, transport layer. That's why transport layer is called as the heart of OSI model. It is the main layer actually. Then network layer is called as network layer in both the models. Some models, I mean, TCP/IP model also calls network layer as internet layer. If you can see here, they have called it as an internet layer. That's also correct. It's not wrong. Network or inter-network is same thing only, right? Internet or inter-network, it's same as network. And finally, the bottom two layers are combined into one layer. We call it network access layer or network interface layer, but we mostly call it as a interface layer, the network interface layer or the network access layer. There's so many names actually, right? But if I talk about the Wikipedia one, which is like what they have shown here, we call it as link layer, right? So not data link layer, but just link layer, which combines both the layers of data link layer as well as physical layer. Okay,
Okay.
I hope it is, yeah. So this is a shorter form, a summarized form of OSI model, and which is again very much utilized today in almost every, I mean, every environment, be it networking, be it cybersecurity, right? People use these layers, they understand these. Even if you do the labs also, in lab also we have to make sure that we we can uh, we can check the flow of packets layer by layer, right? So this is like a very much important, right? So that is about the models, yeah, the difference between TCP/IP and OSI model. Okay, so here we have 7 layers, and here we have just 4 layers. Okay, I hope this is understood. So
Yes.
that is all from my side for today. If you have any questions, please ask.
So
I
far,
hope
no
the session
questions.
was I hope the
Ye-
session was fruitful. It was understood.
Yes, yes, it was good.
Okay, okay. So I'm glad, and yeah. So then tomorrow we will continue, and I will take at least 1 or 2 more sessions to summarize the networking part, right? And then we'll progress more to the cyber part. Also, as I said, the feedback is always welcomed. If you give me started with on the first day itself on Tuesday. We started on Tuesday, right? Yeah. So Tuesday we discussed about these basics of networking. Alice, I'm sure you are also aware of computer networking concepts, at least whatever you have read in the college maybe, or general concepts. Are you aware of these things? For example, we have got protocols, right? We have got devices and technologies of cablings and wired and wireless media. What is networking, Alice?
Yes, I vaguely remember.
Hmm. Okay. So just why I'm saying you, why I'm telling you this, and why I'm asking you all this is because cybersecurity has got a lot of its concepts, and the lab as well is very much related to the networking technologies, right? Without understanding networks, we cannot understand how an attack happens, how attacker penetrates the network, right, and how to defend it, right? So that's the reason we started with the basics of this computer networking, right? So let me just quickly
Yes.
quickly give you a brief idea, Alice, right? Because since you're joining
Yep.
for the first time today, right? Just if I tell you the basic understanding of how the industry is evolving in cybersecurity. Cybersecurity today is in huge demand, right? And a lot of people from various backgrounds in technology, obviously in tech, they're moving and switching towards cybersecurity, right? Because of the demand it has, because of the number of users we have on the internet, it has boomed, it has exploded in the last, let's say, I would say 10 years. And it has created huge number of vacancies and huge number of you can say jobs in the sector, right, in the IT sector. And if I just give you some idea about this, a lot of companies, they have their own products. For example, we have firewall companies. You know what is a firewall, right? We are aware of firewalls. Firewalls are security products, and they allow us to secure our networks, right? We have got a network, we've got a lot of devices in our office, we've got computers, laptops, servers, printers, right? That's a network, right? And then in order to
Yes.
secure them, we use firewall, a lot of antivirus products, endpoint security, application security, data security, right? A lot of different domains are there in security. So firewalls are just a separate area which come under network security, right? Network security is again part of cybersecurity, right? It is one of the domains, one of the parts of it. And so I was saying that firewalls have got their own set of jobs in the market. So if I talk about these vendors, you have so many vendors of firewalls which again hire in cybersecurity domain. So they may call it network security, but they also hire in cybersecurity as well. So it's both, right? So if I just give you some idea, we've got Cisco. Cisco is one of the most widely used devices. It's a big company, right? Then we have got Fortinet, Palo Alto. You can see the names here. Palo Alto is again on the top in firewall, right? Palo Alto, Cisco, Fortinet, Zscaler, Checkpoint, right? So many vendors are there, and each of these companies, they have their own you can say technology, their own platforms that they offer to clients, right? But the cyber security fundamentals are common across all these. Like if you choose anyone, for example, if I show you this one, this is Zscaler, right? Zscaler is actually uh, a very good cloud security company, right? A security company, a firewall, actually a replacement of firewall. They also give the concepts that they use, the basics that they have is totally common with what we have in Cisco or what we have in the Palo Alto or in any other vendor, right? So the fundamentals are exactly same. And if I tell you about the fundamental topics, let me open that as well for you so that you can understand what I'm talking about. Only the what I'm saying is only the specialization part is different. The platform may be different, their features may be different, a bit different, but conceptually cybersecurity concepts are totally same, exactly same all across the industry, be it uh, Palo Alto, be it Cisco, be it any other firewall, or let's say be it Deloitte or TCS or Accenture or Wipro or HCL, any company, they all have the same because the industry is same, right? So they all have the fundamentals exactly same. That's the reason they ask for these certifications, like the general certifications in the industry. This is a very sought after certification, this Security Plus, right? Tilaga, we have already discussed these things. I know that we have discussed these things in the class. Uh,
Yeah.
Hello, Vinaya. So just because Alice is here for the first time, I mean today she's starting, so
Sure,
I'm
sure.
just giving you a brief overview, right? So that she's
Okay.
also on the same page, right?
Yep, sure, sure, Raman.
Yeah.
Yep.
So I was saying that these are the topics, and you will find these topics, for example, security control measurements, physical control, administrative control, right? Technical controls, or let's say encryption. These concepts are you will find all across the industry. And let me tell you, these concepts, like the concepts of cybersecurity, the fundamentals, they comprise of more than 60% in your interviews, in your exams. Only 30 to 40% will be specialized of, let's say, some platform, some particular company. But if it is a general interview for a general, let's say, a service-based company like TCS or, a Wipro at Accenture, they will all start with these concepts only because these are the major conceptual part. Are you getting my point, Alice? What I'm saying here,
Yes, yes.
right? So this is the good thing about it. This is something really good because once we have the fundamental conceptual level and understanding, we can adapt to any platform. We can use these concepts and use any platform, be it for any vendor, be it from any company, right? It's just the difference of their interfaces, their platform, their dashboards, and some extra features that they offer. Otherwise, the basic concepts remain same. Okay, so that is the gist of my what I've said so far, right? So that's the reason these concepts are so much in use. They're so much popular these days, right? And again, we've got so many certifications. I mean, some are specific to vendors, some are specific to just general neutral vendor neutral certifications, right? Like second one is this one that I also showed others. So these two are really popular as well as um, very much in demand, right? This is the fundamental entry level certification that anyone can start and self study and pass it if they, I mean, spend some time, right? So you will find in this also in ISC2 also you will find this the very first level certification of cybersecurity, which is the CC1, the entry level cybersecurity certification. Anybody who wants to enter cybersecurity, they start with this. And as a matter of fact, it's not difficult at all. At least I have not found it difficult. Even I also had to switch to cybersecurity at some point in my career from networking. And because networking is very much parallel to cybersecurity, I found it like it was not very difficult, right? And also for you guys also, it is not going to be difficult once you understand the basics. I mean, in these classes that we are doing, right? So I'm sure you will be able to crack these like once we complete our training. And even not just this, these are the really basic ones. We can even go for a better and even higher advanced certifications, right? So Security Plus is again very much in demand these days, right? And for that, and for Security Plus, the prerequisite of Security Plus is the networking part, right? That is why we have started networking for the past 2 days. And this is the one, computer networking from CompTIA Network Plus. So this again is the exam that judges you, that tests you on these computer networking concepts, right? So that is a prerequisite. That is a minimum requirement that they ask before you start into cyber, right? So that is the whole point, and that's the reason I just told you about the background of it. So Network Plus is what I'm talking about. We have CCNA also. CCNA also is a very popular one, right? But anyways, this is also they also give you these point by point, a topic, so that it is easier for you to understand and upgrade, to learn these concepts one by one. So just keep these also in your list, right? That these are the topics that we mostly cover and try to complete as as thoroughly as possible, right? And yeah, then cyber is a huge space, and I was just telling you about cyber now. So cyber has got majorly three types of jobs. Just to give you the introduction, we have got cyber, um, we call it the red team, the blue team, right? The red team versus the blue team. Red team are the attackers, or at least those who test the weaknesses of our systems by attacking it, by at least uh, duplicating the attack or simulating the attack. It's not a real attack. These are our own engineers and testers. And blue team is a defense team which defend these things, right? They help us to defend the attacks, right? So generally, we categorize cybersecurity in these two, you can say, um, categories: the red teams and the blue teams, right? So security, which the type of, I mean, the subject that teaches us how to penetrate a system. For example, how to hack a server, how to hack, for example, any company's server. Like, let's not take names, but any company's server, or let's say a host, a mobile phone. These techniques are being taught in this offensive security. Ethical hacking. Ethical, why ethical? Ethical because we want ethically, without any legal repercussions, without any legal problem, we want to ethically hack something just to test it, just so that we can test the strength of our network, right? It's very much important, right? It's very important. Then penetration testing also comes here, right? Black box testing, social engineering. We will discuss these things in detail. And in blue team, we have defense. Now, when somebody is attacking, we also want to prepare for the defense, right? So in this, we have a lot of things, right? From SOC analyst, the security operations systems that we have, right? Network operations center and security operations center. We call them NOC and SOC, right? These are again very much in demand these days. These NOC analysts, SOC analysts, NOC specialists, SOC specialists, right? These are like one of the widely and one of the entry level jobs that we have in the market these days, right? So security operations center and network operations center. Companies like Google and Microsoft also hire for these, right? I mean, even those companies, these like top end companies also hire for these roles, right? Because they also have to secure their network and their cyber infrastructure, right? So this is again a type of job, right? I hope this is understood for all what we are discussing here,
Yes. Yeah.
right? And then we have
Yes.
got like not just SOC and NOC, not just the monitoring part, but also the um, complete technical thing. I mean, the technical, I should say, training and certifications, which are for penetration testing. This one. These are the guys who actually test networks. These are the team, the people, the testers who test the vulnerabilities, the weaknesses in the systems, right? This is also very much in demand. If you open the LinkedIn and you search for Deloitte, companies like Deloitte, uh, EY, right? These big four companies, they are highly and very much hiring in these areas, in penetration testing, and in cybersecurity analysts, SOC analysts. every company has these things in demand, and this one is the like the top architecture level certification, this one, security x, right? And this has everything, like this is a advanced level, the final level of the security certification by CompTIA. And this has almost everything, right, from the governance part. As I was telling you, we have got red team, blue team, and the third part is the governance part, which is this. The governance part allows us to create policies, policies and risk assessment techniques, life cycle of everything in a system when it comes to cybersecurity. Like we have ITIL, we have policies for cybersecurity as well, right? So every process has to have some kind of policies and standards. That's the reason GRC is also very much in demand. If you simply just look for GRC jobs, you will find a lot of such jobs across the world, right? And these jobs do not, like they are not they do not require very much technical knowledge of networks or cyber, but this is more towards the management side. But still you need to have the understanding of how cybersecurity works, what are the frameworks, how does it actually work, how an attack happens. So technical knowledge you need to have, no matter whether you're going for governance department or GRC department or some red team or blue team, right? So these, like this is something concerned with the policy making and risk and assessment of the compliance of the systems, right? So again, these are really in much demand. And then comes the hardcore technical things, like for example, we have got DevOps concepts also here, right? You must have understood, I mean, you must have heard about DevOps, cloud computing, right? Everything. So this is the highest level of certification that this CompTIA offers in cybersecurity, right? Security engineering, automation, cryptography, right? So don't worry about these. We once we complete the basics of these, we will be getting a good idea of what these things are, what these terms are, right? Sandboxing, right? So everything is there, like this is a top one. So again, if you are looking to excel in this cybersecurity domain, security x is the top notch certificate that they offer. And similarly, in in this you have the CISSP. This is a top notch one, like the highest certification everybody wants to achieve, right? The CISO, the Chief Information Security Officers that we have in companies, these CISOs are hired on the basis of these certifications only. I mean, they obviously have decades of experience, like 10 to 15 years of experience is a minimum that they want. But on top of that, they require degrees like CISSP that I just told you, right? So this is the, I mean, the top job that we have here, the CEO level job that we have here for cybersecurity, which is Chief Information Security Officer. And they manage everything. The whole cyber teams are being managed by these CISOs, right? I hope you know about CISO, right? It's a very popular role,
Yeah.
right? So this is the path I tried to tell you all, right? This is a path we are trying to move towards, right? At least from the beginning, we should be aware of what all are the benefits that we are going to achieve by this training, right? So you should create, I mean, you should have a good understanding of these things, and then you can decide which path you want to take, which career path you want to take, because you're switching from your current job, and it is a big decision that once you are in the job, you have to decide what path to take, because once you take it, you cannot just go back to the older one, right? So it's a big decision. So again, I just gave you some idea that what all paths do we have. But the good thing is everything starts from the really basic structure of cybersecurity. So whether you start from CC or whether you start from CompTIA Security Plus, which is a very fundamental level exam, everything, I mean, you will find the content very much similar to each other when it comes to the basics, because fundamentals are always very similar to each other, right? So that's what we're going to discuss here, okay? So just to give you an idea now, so you can just look into these. I mean, I will definitely share these with you also. So now we'll move forward with the topics, okay? Let's not, yeah, this is for CompTIA level exams, right? and this is for ISC2 level. I mean ISC2's exams that are there, and this is actually free. So they also give free voucher and thing, so you can just pass the exam and take the exam. You have to pass a practice test and then you can give the exam, right? It's free. So now let's come back to the discussion. So the general concepts that we have. So let me show you the general concepts that I'm talking about. These ones. The domain one, the security principles. They talk about the basic principles of security, right? Like the confidentiality, integrity, and availability concept, right? Of the CIA triad, as we call it in cybersecurity. It's a very popular one. We call it the CIA triad, right? It's you will find it in every cyber security or information security area, right? They will they talk about these CIA, the confidentiality, integrity, and availability, right? I'm just giving an example here. I'm not talking about this in detail as of now. We will talk about these things in detail, but not now. And then similarly, we have got principles like, for example, we've got a principle called as the principle of least privilege. This one. It's a principle of cybersecurity without which we cannot design any system. What does it mean? Just to give you a summary, it means that we have to assign access to people as only as much as they require. We don't give all the access to all the employees, right? Isn't it? We don't want everyone to know everything because that can pose a security vulnerability, a security risk for us, right? Because we only want to give access to people, only that much access that is required by them for their job, right? That is all. That is called as principle of least privilege. It's a very popular concept, right? And then similarly, we've got so many concepts. Like if I start telling you about these, like it is so all these concepts come under these security principles. Then we have access control concepts, how to give access to people, app for applications, for networks, what access actually means, read access, write access, and access to change things. Network security is totally about networking, totally about networking and firewalls, port numbers, right? Protocols, everything. And which I was talking about in the beginning, the firewalls. And then we've got security operations. That is where the management of day-to-day escalations happen, right? Escalation in clients cybersecurity environment. We are the service provider, so we have to maintain that, right? Security operations. And as someone, I think Tilaga said that she is doing SC200, right? That is totally based on cybersecurity operations, right? This is the certification. This is the uh, go-to certification for operations analyst role. If somebody wants to work in SOC, especially in Microsoft environment, right? This is Microsoft specific. So yeah, so that is what I'm saying. So these are products of Microsoft, right? As Microsoft is again a huge has huge presence in technology, so definitely it has its own products. So that is the whole idea. Okay. So let us come back to the discussion. In yesterday's session, I discussed a bit about networking, and I discussed a bit about the OSI and TCP/IP model. Right. Let me open the file again. And we were discussing about how a packet flows in the network, because unless you understand the flow of packet and what actually data is, we are trying to secure cyber security space. It means we are trying to secure our systems, our servers, printers, you know our data, first of all, because all these things have data in it, right? We don't want to lose our data on the server. We don't want to lose our emails, or at least so that they don't get leaked. So the main purpose of cybersecurity is to protect your data, right? That's the main objective. When I say cybersecurity, it means securing the cyber environment, securing the systems from any attack that can come from the internet, right? Mostly internet, because external attack, it can also come from the internal people. We call that insider threat, right? So you can see these are the like go-to points that we have, right? So cybersecurity is the one. The rise in, I mean, if I give you just one line definition, is the practice of protecting systems like your systems, your um, let's say your salary giving system, the salary crediting system, or let's say the account system. Your HR has a lot of data about individuals, right? Who's joining, who's not joining, what is the salary of some person, or a team. So they don't want to lose that data, right? Anyone can attack these systems and can infiltrate, can extract those data from their server. That is the theft we are talking about, right? So we want to protect from that. We want to protect the system from such attacks. Okay, networks, programs, even your applications can get hacked, right? They can destroy your application. So it's not just extracting data, it's also, they also destroy it, they also like make it useless, right? So there's so many types of attacks, the intentions are so many. One is to exfiltrate the data, one is to destroy the data, one is to change the data, right, to make the data unusable, right? So there's so many ways these are done, and there's so many motives of the attacker. Somebody just wants to steal information for their purpose. Let's say your competitor, your company's competitor is another company, and they want to exfiltrate the data, share, I mean, leak some data out, or let's say they are they don't want you to progress, so they can destroy your systems, they can destroy your data, right? So there's so many motives basically. So that is what cybersecurity is. It's a practice of protecting systems, networks, and programs from digital attacks. And we have a long list of attacks that can happen. Like what all people do these attacks, like that the we call them cyber attackers, for example, in a basic terminology, cyber attackers, right? So many types of attackers are there. Like we've got so yeah, I'm going to give you a structure completely, but so in cybersecurity, like these are the malware, these are the cyber threats. What threats do we have? So cyber threat, we have malware, we have ransomware, right? So many types of systems we have that can be used, right? And that actually become a threat for us, right? Malware, ransomware, phishing, spamming, social engineering techniques, right? Then in attackers, we have, hackers, then what we call as the state-sponsored ones. Some countries attacking some other country, state-sponsored, right? We've got, I mean, we call them cyber mafia, right? They are just group of people who are doing it for profit. They are running a business of cyber attacks, right? So we call them cyber mafia, or let's say organized crime, organized cyber criminals. We call them cyber criminals, right? So there's so many types also of those people who attack. Then we have hacktivists also. Some people want to hack just for a cause. They are activist, but they are hacktivist, right? So you will find these things in the on the internet. You will have a long list of people who act like this cyber attackers, right? So some are extorting money from ransomware, right? So that is what we have to protect against. Okay, so that was just a summary of how what all things we are going to see in these things, right? We've got a lot of concepts here. You can see here best practices and everything. So I'll give you a structure. Don't worry. I will give you my own structure, the way I explain things and how I explain the flow. The flow is important, right? So the flow allows you to understand how to proceed in the learning. Okay. So we'll do that. Don't worry. Just that today I'm gonna come back to the basics, the very basic discussion of networking that we were doing. So are we on the same page now, Alice and others? I hope you've got the idea now,
Yes.
right? So let's begin. I mean, let's start with the fundamentals. So fundamentally, we're talking about systems, protecting network. We need to understand what networks are, what systems are, because today, even if you are talking about even a basic phone that you use, your mobile phone, that is connected to the internet. Your PC, you use Wi-Fi for that. In your office, you have a workplace workstation, right, or a laptop. That workstation or a laptop that you have, I mean, your personal laptop, it could be a workstation, that is connected to the internet through Wi-Fi, right? I mean, through network, some kind of network, a LAN network or a Wi-Fi network. So you need to understand how these things actually work. Unless you understand the flow of packets and the the technicalities, you won't be able to understand the bigger picture, right? So that's the reason we have to start from here. And don't worry about these things that what we are talking about, IP addresses and port numbers and all. These are really simple. We only are afraid of things we haven't studied. Once you study them, it becomes easy for you, right? It becomes easier. So that's the thing. So in a network, yesterday I just gave one simple example that when we have a sender here, a sender computer, and this is a receiver computer, a sender device, a receiver device. Basically, someone is sending some packets across from PC, this PC to this PC. How the packet will flow, how the data will pass on to the other device. So for this, we have created certain frameworks. For example, OSI model. OSI model is the one which is the go-to model for networking. It tells us how data is actually sent from one device to the other device, along with other details, other addresses. For example, if I just give you some idea here, you can see this is my laptop, right? And my laptop has got this. If I say ipconfig, ipconfig is the command that I use to check the details of my network. So here I've got a wireless LAN adapter, Wi-Fi adapter, right? My IP addresses are there. And if I just also show you ipconfig/all, this command ipconfig/all give me a detailed overview of all these things. So starting from my MAC address. MAC address, as we have discussed before also, these are physical addresses. These are not, there's a never change. These are fixed right from the time of manufacturing. Once you manufacture a device, once you manufacture a laptop, it has a Bluetooth connection, or let's say a Bluetooth chip. It has a Ethernet chip, a LAN cable chip. It has a Wi-Fi adapter like this one, the Wi-Fi adapter that it is using right now. All these network interface cards, be it for Bluetooth, be it for Ethernet cable, LAN cable, or be it for your Wi-Fi, all these chips have certain ID given to them. That ID is called as MAC address. Clear? It's simple. It's really simple. Every hardware device will have it. Even your SIM card has some. Even your mobile phone has a MAC address. Even your Wi-Fi router has it. All these devices that can communicate on the internet, they definitely have a MAC address. That's one thing. Okay, so that's a MAC address. It's a very simple address that is going to be used a lot in your career once you go into cybersecurity, or let's say technical side of the cybersecurity. You will be using it, and I mean you should at least have some idea about it, right? So these are the addresses that you find and you see on the chips, the network interface card, as we call them, the NICs. We call them the NIC. NICs are nothing but network interface card. So these are the adapters or the chips that simply get attached to your motherboard, right? I hope you know what is a motherboard. Motherboard is what? What is a motherboard? Guys, I hope you're following, right? It's a simple motherboard, right? I hope you can
Yeah.
follow what I'm saying. So a
Yes.
motherboard
Yes.
is one that has all the components, hardware components attached to it, embedded onto it, fixed to it, so that we can use like so many functionalities in a small using a small board, using a small laptop. That's how the size is basically squeezed down, right? It is decreased so that we can have smaller devices, handheld devices, portable devices. Okay, so these additional cards are simply placed here as a network interface card for Wi-Fi, for Bluetooth. And these are the older motherboards. Let me tell you, today laptop motherboards are even much sleeker and much better, right? And the chips are even smaller. This chip is anyways very old, which I was just showing you. This one, it's a older chip for desktops, right? But anyways, this is the idea. These are NICs. NICs have a fixed 48-bit address, which we call as a MAC address. Now you would ask, what is a 48-bit? 48-bit is nothing, just that we talk about ones and zeros, right? In computers, yes or no? When
Yeah.
we talk about computers, we talk about ones and zeros, we talk about bits. So don't worry about these things. These are just conceptual level things that we have to at least be aware of, right? So if you look closely, this is A8, A795, AA8E5F. You will ask me, how is it 1 and 0? It's not ones and zeros, right? It's
Yeah.
A, F, and numbers. So why are we calling it that it is a 48 bit? If you look closely, this is actually written in a hexadecimal notation. Now, I don't want to go into the technicalities of number systems. I don't want to take you back to your BTech or graduation first year. These things are usually taught in number system in graduation first year. Just to simplify this for you, one hexadecimal character, which we are using in MAC addresses, is equal to 4 bits of binary. That is all. So you can have 4 bits of binary in one hexadecimal character. So if let's say I'm taking hexadecimal character, let's say as let's say 1, in binary it will be 0001. As simple as that, right? For 2, it will be 0010. So don't worry about this. It is just the notation that is there. Don't worry about these conversions and all. You don't have to worry about that. Nobody asked that in your job, right? Just that these are how we squeeze them down. Instead of writing a 48-bit address of let's say so long, right? We simply pair them in 4 4-bit and replace them with one hexadecimal character. That is how we get this number. So if you look closely, A will be 4 bits of binary, something 8 will be in 4 bits binary. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 fours are 12 fours times
48.
4 times
48.
48, right? So if you see, a MAC address is nothing but a 48-bit address that we use, and it's a 48-bit address, means it has 48 ones and zeros, but it is written in hexadecimal notation. So don't have to worry about it. We call it a 48-bit address because it is in bits, but generally we write it in 12 digits of hexadecimal identifier. So don't just worry about these hi-fi terms that it is hexadecimal identifier. Oh my God, what is this? It's simple, right? It's just numbers, and they have tried to squeeze it down so that we don't have to write it such long characters again and again. Imagine you have to write 48 bits every time. It will be a huge task. Yes or no? You cannot just write 148 ones and zeros every time. So just to shorten it, they've used hexadecimal. Okay, that is all. And just to add on to this, because we are on the same concept here, IP addresses, which are especially IP version 6 address, are also in hexadecimal, as you can see here. And if I tell you something really scary about this, IP version 6 are actually 128 bits long. So you would say like 128 bit is a long list of bits, right? If you keep on writing this, and it will be a huge task for you to write 128 bits. Just imagine writing 101010 how many times? Whatever, 128 times. 128 10s, right? It will be a huge thing for people to write. That's the reason we have replaced them with hexadecimal. I mean, we have used them as hexadecimal, so we get this, a shorter notation, right? So that's the basic idea of how things are represented. Instead of long binaries, we try to squeeze them down to smaller notations. I hope this is clear now.
Yeah.
So these are real things. I'm not talking about any conceptual thing which will not be used in the future. These are actually real things. We are looking at a system, at a live Windows machine. This window machine has this IPv4 address, IPv6 address, right? These are really simple things, and these are used. So just don't get intimidated by these, I mean, numbers, or let's say the mathematics behind it, the conversion. These are not going to be our job, right? Unless we are part of some research and development work in cybersecurity, we will not be dealing with these conversions or, the mathematics of it. We will be talking about the concepts. We will be talking about the attacks, the tools, how to prevent these attacks, how to secure the network better, right? So don't, I mean, if it is scary, just don't worry. We will not be going into such details of the mathematics. Okay. So that was about it. Let's come back to the discussion now. So Yeah, so that was about the general idea of what we have in place. So every yeah, back to the example here. So whenever we want to send a message across, the message requires three things. Yesterday I told this, we were discussing it. Only Vinaya was there, so I'm just going to repeat it once more. So one is the port. Let's talk about the IP address. So IP address is the first address a packet wants. When you are sending your when you're sending a letter to your friend, let's say a letter, like today we use mobile phones, we use WhatsApp and emails, but let's suppose you want to send a letter, a courier to your friend, to your family. You simply use a letter, put it in the envelope, and on the envelope you write some addresses. You write your name of your friend, and then you write the address of your friend, the house number, the building number, the society number, whatever, and then the area, the neighborhood, and then you write the city name, state name, and the zip code, the pin code, right? These addresses allow the postman to take the packet, take your letter, and deliver it to the right destination. That is exactly how networks also work. That is how exactly why, how we send packets across on the network. So IP address is the first type of address that we have to write on the envelope. Envelope means the envelope of my packet, of my data. Data has to be put into the envelope. That is what we call as encapsulation. Remember, we discussed that. So we simply try to put our data packet on the envelope, within the envelope, and we give certain addresses. One is IP address. The second is the MAC address, and the third is let me write it here. Okay, the third is port numbers or port address. Okay, now that is all we have to write. These three addresses are the basic requirement of any packet. Once you give these three things, the packet will be able to reach the destination. Okay, now what is IP address? IP addresses are addresses that are required by computers and servers and any kind of machine that is on the internet. If you want to use the internet, you must have an IP address. Without an IP address, you cannot communicate on the public internet. It's impossible, right? So that is what IP address is. It's just a address given on a given for a computer, for anything, for any machine, right? So usually we have these IP addresses written in this form. I mean, in just simple dotted form like this: 192, 168, 1.1, right? Like I just showed you also. This is IP version 4. Version 4 is the older version. Version 6 is the newer version, as we have just seen, right? So these addresses are important, and using these addresses, the packets reach the correct network on the internet. Internet is a huge space, right? And we must have some IP addresses also, so that we can send the packets across. So these are basically like a house address of your house in a city, in a world. Similarly, on the internet, we have IP addresses for the global internet. Okay, so anybody wants to come and reach your place, they have to have some kind of address. So this is what IP address is. And then comes the next address, which is MAC address. MAC addresses, as I just told you about that in detail, it's a fixed manufacturing manufacturing address. I mean, it was fixed during the time of manufacturing, so it is the physical address. We call it the physical address. IP address is a logical address, but MAC address is called as the physical address. A lot of times these terms are used interchangeably. Okay, some people say physical address, some say MAC address. So the packet is coming using IP address, it reached the correct network in the world, in the country, in the city, wherever. Using the correct MAC address, it reached the correct port number. I mean, sorry, the interface. You would be using Bluetooth, you would be using a LAN cable, you would be using a Wi-Fi. No matter what technology you're using for transmission, your MAC address will immediately, correctly receive that packet to itself because of the MAC address. So if you can see here, Bluetooth NIC has got its own MAC address here, right? This is Bluetooth NIC, Bluetooth chip, and Wi-Fi chip has its own MAC address. Can you see? I want some answers here.
Yes. Yeah.
right? And similarly, your LAN cable, I mean your Ethernet cable, it is Ethernet cable we call it, Ethernet adapter. This has its own MAC address. So without a MAC address, we will not be able to understand, the packet will not be able to understand how to reach the which control we are using. We are using Bluetooth card or LAN or through Wi-Fi. What are we using actually, right? So these ports are, I mean, these addresses are important. Okay, I hope this is clear.
Yes.
So right now I'm using Wi-Fi. My content is coming from Wi-Fi. So it will be using this port number, this MAC address, sorry. Okay, not port number. Port numbers are the third ones. So that is physical address, and then comes a port address. Now what a port address is? Finally, my data packet has reached the correct network. My data packet has reached the correct interface through Wi-Fi, let's say. But on the same machine, I am using Google Chrome here, internet. On the same machine, I might be using this Teams call, right? I'm having this conversation here on the call. And on the same machine, I might also be downloading something. How does the packet recognize to which service it belongs? Have you ever thought of this? Like a single computer with a single Wi-Fi connection with a single IP address, how does the data packet know that it belongs to my Teams calling session, my video call session, or Teams call session, or let's say my browsing session, or my downloading session? How do they know? I could be using an email also. An email is also coming, right? So for that, that is the reason why we require these port numbers. These port numbers are different for different services. For email services, you have different port numbers. For um, for your uh, internet browsing, you have different port numbers, right? That is when port numbers come into picture, right? Now, once you give the port numbers for different services, for example, for web services, we have HTTP. It's a very popular one. We have discussed that already. The port number is 80. For file transfer, for file uploads and downloads, we have FTP. FTP has port numbers, I think 2021, if I'm not wrong. FTP has 2021. Yeah, right, correct. And then if I have to have mail, I have SMTP. SMTP is a protocol for emails. The port number is 25. Got it? So using these port numbers, the data packet, this guy knows it belongs to an email service. It is a part of an email, or let's say a file download session, or a web browsing session, right? Using these port numbers 80, 20, 21, 25, they have just fixed it. Okay, so you've got a long list of such port numbers. So using these port numbers, the data exactly knows where it belongs. Clear? Guys, I hope this is understood to you. I mean, this is an important concept, and I've summarized it as easily as I could. Yes, Alice, Vinaya, Tilaga,
Yes.
Yes.
Yes, Ahmed. Yeah.
Yeah.
right? So these are three other, I mean, addresses that are the bare minimum for the packet to reach the correct destination. And destination is not just a computer. Destination is IP address for network, MAC address for correct interface, and interface means the technology you're using, Wi-Fi, Bluetooth, LAN cable, and finally the port number for services. Because same system, like my same system is using so many things. My same computer on Wi-Fi with a single IP address is using Chrome as well, Notepad, Paint, Task Manager. We are using network services also for Teams, right? Downloading session, downloader, and everything. So they differentiate using port numbers. Okay. So I mean now we are we are done with it. Um, and tomorrow we will be moving further from here. And as I said yesterday also, we will be taking at least three four sessions more to develop the understanding of networking. Okay, fundamentals. Let's say some IP addresses and the details of how ports work, right? And also some aspects of routing and switching, also the basics aspects only, right? Not in detail, just which is enough for us to understand the cyber fundamentals also. Okay, and then we will be moving to the cyber concepts. Okay, so as a foundation, I want to spend some time on networking. Okay, and So that is it. Let me tell, I mean, you let me know if you have any questions. Yes, any question, any
Oh,
doubt?
No questions.
Okay, okay then. So please, I mean, revise these things really well, and you can take the screenshots also if you want. And that is all. We'll meet tomorrow at 8 p.m. sharp. Okay.